Hello everyone. So today is day 55 of DSA problem solving. So the problem we are going to discuss is factory machine and second in room allocation. So in factory machine what we had to do is let's just try to read the problem. A factory has n machines which can be used to make products. Okay, we have n machines which can be used to make products. We have to produce t products by the end. Okay, so we have n machines which can produce products and by the end we need 10 products. And for each machine we know that the number of seconds it need to make a single product. Okay, so there it takes 3 seconds to make a single product, it takes 2 seconds to make a one product, 5 seconds to make one product. Okay, so let's say if t is equal to 5, so it will give one product, it will give two product, it will give one product, so total will be 5 to 7 8 products at t is equal to 5. 5 is equal to 1. Okay, sorry, t is equal to 5 with one product, then two products and one products. Okay, now four products at t is equal to 5. Great. So what is asking for each machine, you know the number of seconds it needs to make a single product. Yes, we know that. The machine can run simultaneously and you can freely decide their schedule. Okay, what is shortest time to make t products? Okay, we have this constraint and can vary up to 2 10 power 5, t 10 power 9, and ki means the time taken to make a single product is 10 power 9. Great, and t is total products we need to make. Okay, so you can take like just pause the video, try to solve this question, think it through, how will you solve this. Okay, so now let me share my approach. So I was asking the shortest time needed to make the tea products. Okay, so I just thought of like going binary search on the answer, like on the possible time. Okay, so let's say there is for time 100 it is possible, so we will check if time 50 possible, 50 possible. Okay, then try 40 50 25 possible, like this. Okay, so let me just share my code. So its implementation about bit interesting. Okay, so this is the part. So what we did, we defined a vector or v. So this is the vector which was given to us. So this vector, okay, and we starting find from start end, and we kept an answer. Okay, so okay, and also you have to think of why I'm keeping end as like 10 power 18, why not 10.9 or something smaller. Okay, so try to think it through, like this is part is very interesting. Let me just give some idea. So this is okay, so let's just take the edge cases only. Let's say we need to produce 10 to the power 9 products. Okay, and producing a single product take 10 to the power 9 time seconds. So how much, single products take 10 to the power 9 and we need 10 to the power 9 products, so 10 to the power 18 would be the answer. Are you getting the point? Let's say n is equal to 1 and we need 10 to the power 9 products and the time taken to produce one product is 10 to the power 9. Like unitary method no, to write a page unit 10 days, 10 minutes, sorry, to write a page. And in 1 hour, how many pages you will write? So 10 minutes into 6 pages, simple unitary methods. So getting the edge case, like how much things will vary is important. Okay. Rest is simple binary search. We got the mid. If products, we define a function like how many products will we get with this mid and v vector and time total products. If we get an equal to t, then answer is equal to mid. I am keeping the track of the answer, and end is equal to mid minus 1. Okay, go for smaller range. Else go for bigger one. Okay, let me define the products. Products is simply written that if we have the like mid amount of time, so how many products can be produced? Okay, if we can produce the products more than the required one, we should reduce the time. Okay, if we are getting less time, we should increase the time. Very simple concept. Okay, why I'm discussing the problem, because we need to be very careful of the constraint. So this part was important. Okay, like I did a mistake here, so I am, that's why I'm repeating this again. And this part is like when we define the products, you will see that okay, the like while summation, the range may exceed 10.18. So we need to keep a filter or something like or a filter or some kind of threshold. So if you're exceeding t, okay, just return answer, we don't need it. Okay, this won't be the answer. Just try to think of this part. Okay, so I think this problem was interesting because we need to think of very careful with the constraints. And yeah, submitting or getting the right answer in the first attempt is tricky but important, yeah, because we need to think or be very careful in such problems. Okay, So let's just move to a second problem, which is room allocation. So from the name only you will be like thinking like it should be something greedy, because it's bit of standard problem we can say. But I have seen this problem solved by Love Number 2 and on Lead Code also. So there is a large hotel and customers will arrive. Each customer want to have a single room. Great. You know that each customer's arrival and departures date. Okay, we have each customer's arrival date and departures date. Two customer can stay in the same room if departure day of first customer is earlier than the arrival day of second customer. Okay, so matlab, the departure day of first customer is earlier. They can't be same. Okay, so this point is expressed here. So they same, they can't stay in a single room. They must be different. Then simply ask what is the minimum number of rooms that need to be to accommodate all the customers. Okay, what is the minimum number of rooms we need to accommodate all the customers, and how many rooms, how can the rooms be allocated? So this part is interesting. Generally we don't need to mention like this, like mention like which customer will sleep or rest in which room, but here we also need to mention that like which rooms will be allotted to which customer. Okay, we see the constraint first. So we have customer up to 10, 205. Great. And A and B like arrival and departure day 10.9. Okay, so here let's say the first customer is, we allotted him the first room. Okay, let me say the method I did. Okay, so first I just really sorted by the start date only. Okay, then I use min heap to process further. Let me share my code only. Okay, this is room allocation. Great. So I created a tuple first. Okay, so its implementation was a bit trickier from, so that's why I'm discussing like things should be interesting if you just simply use. Otherwise you have to use again 2D vector and use a pair inside that. Okay, so this is making things a lot simpler. So we have defined a vector, we kept a tuple inside it for intervals. We kept start, end and index. Why we are showing index? Because we need it actually in the question only. For the answers they are asking us to mention the index too, like how can rooms be allocated. For that we are storing index. Okay, we have sorted by start date, sort index, begin, that, end. Okay, and we defined a min heap here, and in min heap we are keeping two values. First is the end means like the departure date, and the room number allocated to that person. Okay, so initial room count is 0. We're keeping an answer vector. Okay, so we are traversing the intervals like this intervals vector of tuples we defined. Okay, now a simple condition here. This is the simple condition we are checking actually. So if our priority queue like min heap is not empty and the top of the element, like the end of this element, is less than the upcoming start. It's the person is coming. Okay, so his arrival date is more than the minimum departure date we have stored. Okay, so what we are going to do now, if this is the case, we are going to simply pop the top element. Okay, and replace this new element or customer with that. Okay, so see what we're storing. We are storing first the, basically we need the room number of that person. So we are keeping the top of pk.top, and they are popping it, and we are then doing answer of I is equal to room number. Great. And then we are, in particular we are pushing the end is departure date of the new person or customer who is coming, and then the room number. Room number is the same because we are just simply replacing it, and answer I is equal to room number. Great. Do we need answer? Okay, we need to push the answer, return the answer too. That's why we're keeping the answer. Okay, great. And now simply thus, if it is empty or this is not the case, we simply do room count plus plus, and we push e comma room count. So think this part, yeah, this part is not a tricky, but this part is important. It's a simple case we are using to solve a problem. So think, if you want to remember, just we started by sorting the like arrival time or start, and we are using min heap to like keep track of the minimum in date or minimum departure date. And we also need to like take care of the room, or basically we need the question asking to print the rooms too. So for that we were keeping answer vector, and also we were storing it in a min heap along the way. So this is basically the scene. Okay, that's why. Okay, so that's it for today. See you on another day. Bye bye.